Today we are going to talk about converting scientific notation into standard form and then standard form back into scientific notation. So when we're converting between scientific notation and standard form, it's important to remember which one's which. So standard form, if we look down here at C and D, standard form is just that regular way that normal people write their numbers. Scientific notation, on the other hand, is how we're able to write really, really big numbers and really, really small numbers in a more condensed form instead of writing, you'd have one number that could take up half a page, but we could just shorten that into scientific notation and make it more reasonable. We're not going to look at any numbers that are that big, but it's just the general concept that we're focusing on. So, first thing first on this, we have two scientific notations that we're going to convert into standard form. So, on the scientific notation format, it's important to note that we have one number to the left of the decimal place, which is always the case on scientific notation. And then the other thing we need to pay attention to is our exponent. So anytime we have a positive exponent, it's going to be a really, really big number. And then anytime we have a negative number, it's going to be a really, really small decimal number. So we're going to start with a number that we're making bigger. So on A, we have, on the left-hand side, we have this 4.6. So what I'm going to, 4.6, I can't even read, 4.7. So over here, I'm going to write 4.7. Now, where this exponent comes into play is when it's a positive exponent, when it's positive or negative, that tells us how many times we're going to move this decimal point. So since it's a positive 5, this decimal point is going to jump to the right 5 times. So we moved it once, twice, thrice. I don't know what the ice is for 4, so we've moved it 4 times, and now a 5th time. So our decimal point's going to end over here. Now, every one of these little troughs, I call them troughs, that does not have a number in it, we are going to write a 0 in. So 4, 7, 0, 0, 0, 0, and now we hit our decimal point. And we don't need to write anything after our decimal point here, since it would just continue being zeros, and we don't write 0.00000 after our regular numbers in standard form. Or maybe you do, I don't know. I don't. I wouldn't recommend it. So now we have, let's see here, if we add a comma there. So we have 470,000. So our final answer, we would just write 470, comma, 0, 0, 0. And that would be our number in standard form. So since we had a 5 as an exponent, we move this decimal place 1, 2, 3, 4, 5 places to the right. Okay. So now let's practice one with a negative exponent. So we follow the same general procedure. Since we have 3.2, I'm going to write 3.2 over here on this right-hand side in the standard form section. Now, we have a negative 7 as our exponent. So it's going to make a really, really small number. So if it's positive, we move the decimal to the right. If it's negative, we're going to move this decimal to the left. That was a really good arrow. Let's make that a little bit better, because that's going to bother me. So positive to the right, negative to the left. So we're going to move this decimal left 10 places. What is wrong with me today? So we're going to move it left 7 places, since the exponent is negative 7. So 1, 2, 3, 4. Nah, I didn't like that one. That was bad drawing there. So 1, 2, 3, 4, 5, 6, 7. So our decimal is going to end right there. Now, once again, every time we have an empty trough, we're going to put a 0. So 0, 0, 0, 0, 0, 0. So our final answer here is 0.000 1, 2, 3, 1, 2, 3, 3, 2. Now, if you want to add a 0 to the left of the decimal, you can. You don't have to. That's really just personal preference. Some teachers might say you have to have this 0 to the left of the decimal point. In my class and Mr. Wright's class, it doesn't necessarily matter, but that'll be up to your teacher to decide. So our final answer here is 0.00000032. Okay, so negative exponent, super small number, positive exponent, really big number. Okay, now let's practice a couple going from standard form back to scientific notation. So the important thing here is to remember that there can only be one number to the left of the decimal point. Not only can there only be one number, there has to be just one number left of the decimal point. So on C, we're taking a really, really small number and we're making it into we're switching it to scientific notation. So if we have one number that's going to be left of the decimal point, let's switch to red here. So one number left of the decimal point, we start off with zeros all the way until we get to the 3. So I'm going to put my decimal point right here. So my number is going to be 3.2. Did I use the same one? No, I didn't. Okay, good. So my decimal point is going to go between the 3 and the 2. And what that means when I go to write it in scientific notation, my first number is going to be 3.2. And then it's going to be times 10 to the something. Now we know it's going to be a negative something because it's going to be a really, really small number. But how we figure out what that exponent is we have to count how many jumps that decimal point makes again. So we start right here with this decimal and we're going to move it 1, 2, 3, 4, 5, 6, 7, 8 times. And we can count 1, 2, 3, 4, 5, 6, 7, 8 little jumps or 8 troughs. So our exponent is to the negative 8th power. So we're really just doing the reverse of what we did to take it from scientific notation to standard form. So we're really jumping back the other way is what we're doing. Once again, it's just counting how many times you move that decimal point. My recommendation is that you write these out, whether it be on your whiteboard desks, on scratch paper. You don't have to write it in Kami necessarily because that's a chore. But I would make sure you show your work somewhere because it's hard for me to keep track of the counting in my head. So I'd imagine that some of you might have the same issue. So anyway, let's look at one that's a really big number. So when we have a really big number, there's usually not a decimal point drawn in, but if we remember from past years, the decimal point would be right at the end because we could always add 0.0000 if we wanted to. We don't because, well, quite frankly, that's strange. So we draw in that decimal point, and now we have to figure out where we want that decimal point to end up because we need one number to the left of the decimal point and only one number. So if I start going left, I see 0, 0, zeros, okay, a 3, and then a 9. And so if I want one number to the left of the decimal point and everything else to the right, I need to make the decimal point go right here between the 9 and the 3. So my first number is going to be 9.3, and then it's going to be times 10 to the something. And since it's a really big number, it's going to be a positive exponent this time. And then we're going to do the same thing. We're going to count how many go from our original decimal point to our new decimal point. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 jumps, so our exponent is going to be 10. And that is all there is to it. One trick I've picked up on over the years, and it works for me, it might not work for you, it's totally up to you. When I have a really big number, every comma, so there's a comma right here, comma right here, comma right here, I know this is going to be 3 jumps, this is going to be 3 jumps, this is going to be 3 jumps. So I know I've made 9 jumps once I get through those commas, and then I need one more to get to that final 9.3. So if it's a really, really big number, it might be easier to count the commas, but if that doesn't work for you, just ignore it. I'm sure it'll help some. Some will be like, what? So totally up to you if you use that trick or not. So your homework for this is going to be to go down the rest of the page. So we have E, F, G, H, I, and J, and you're going to convert those from either standard form back to scientific notation or scientific notation back to standard form for each of them. So you're really just filling in the blanks for the rest of this page, and that's going to be your homework. If you have any questions, please let us know. We can't read your minds. We need to know if you have questions.